Let me try to share the whiteboard. Okay. Do you see my whiteboard? Do you see my? Okay. So now in the last section we covered every problem of the trigonometric inverse functions. Now we continue. We continue now, for example, identity. Okay. Don't frustrate for this. I know que it's a little bit confusing, complicated. No. In the test I put, no elementary kindergarten example, but doable example. Okay, no sophisticated because there are trigonometric identity I cannot solve it. Or I spend, 2 weeks doing that. No. This is not intention, right? Okay, so let's do it. Remember the idea in the identity, establish or proof, either way you want to call. The job is you have the identity, 16, we are doing 16, que es cotangent theta, multiplication, secant theta. I need to prove que es equal cosec theta, okay? So I use it one more time, the famous, I'm using cotangent identity, que I know que cotangent is cosine over sine. Cosine theta divided by cosine, sine. Multiplication by reciprocal of secant, que es 1 over cosine. And this stays the same. Cosecant x. I make a decision. Manipulate left hand side. Stay right hand side exactly the same. And finally, we put each other equal, no? And you see clear now que cosine is cancelled. And stay reciprocal of sine. Yeah, I know very well que reciprocal of sine is cosecant, but the reciprocal identity. Cosecant theta equal cosecant theta, end the story. I proved that. Clear? Any question?
It's clear, Professor.
I know. I explain clear. You follow me and you have no problem in your life. You are a distraction. Okay, maybe you have problem.
Sorry, Professor, can I take a picture?
Yeah. Oh, go ahead. Take your time. Take a picture.
Thank you. I already took it.
Okay, let's move on to the next, que es 17. 17 say tangent theta multiplication cosecant theta is equal secant theta. Be careful, guys. Bad habit of the student is write the name of the trigonometric function without argument. Tangent times cosecant. This is wrong. This is similar in algebra. Suppose the function notation is f of x, and you write f times g. It's possible, but in this case, no. Okay, I hear some noise. It's noise. Who make a noise? Putting off the microphone. Only when you want to ask me some question, you put it off. I don't want to hear noise, music, nothing. See, I detecting the person that are doing this, I put outside immediately. Okay. Entonces you understand que the trigonometric function without argument is for me nothing, no? Just you put a paréntesis or no paréntesis. In this case, no paréntesis theta. Pero es the argument. Okay, entonces one more time I apply the identity, the tangent, que I know que es sine over cosine, sine theta divided by cosine theta. Do you want I show you the place you can find in my cheat sheet, on our cheat sheet, this identity or no? Or you are familiar? We are the professor and try to render the meeting to be able to see. Okay, guys, I sent to everyone the link, no? And you click in the link and you connect it with me. This is always the same. I don't need to explain this. Noela, you say something?
I said it's not necessary, I guess. So.
Okay, okay, super. Now, cosecant is reciprocal of sine. Yeah, make a decision que the right hand side stay the same. Now you see que sine is cancelled out. Stay alive 1 over cosine. Yeah, you know very well. Reciprocal of cosine is sec. End the story. Any question? Super easy, eh? I don't know, say I put too easy in the test or middle complication. You see, no sophisticated. Regular identity, okay, every student can do that without problem.
Homework, it's a little bit difficult, Professor.
No, don't be scared. Don't be scared. I am no bad guy. You know my way to work. You know, I regular. I explain very well or try to explain very well in the review. You have the possibility to. This is an important moment for me. Any question, minimum question that you understand. Professor, where come from this sign? What is the reason for using this? Where come from this identity? I never see in my life. Okay? O sea, no era say que es no necesario show the cheat sheet in which you can see que tangent is equal that. She said that. Everyone is agree or disagree? It's okay, no? I suppose, no?
Yes, it's okay.
Okay. Another opinion.
Yes, Professor.
Okay, super. Okay, let's move on to the 18. 18 is a little bit weird. It's sine square negative theta plus cosine square negative theta should be 1. Es obvio que right hand side que es 1 stay the same and you manipulate. I need to know the two famous trigonometry identity, even odd, even odd, even odd, even odd. I know que even es cosine, o sea, cosine negative theta is equal to cosine theta. Cosine doesn't affect the sign. I don't care que es negative or positive. However, the odd function, que es the majority of the function, sine affect. Sine negative theta is negative outside sine theta. So it's easy because the negative inside the parenthesis magically go outside the parenthesis. The reason is because sine and tangent also is odd function, but cosine no, cosine is very special. Doesn't affect because it's even. Okay, entonces let's manipulate. Entonces you replace no negative argument. I don't like this. You copy negative sine theta squared. I need to explain something important. I don't know why. When you raise to the any power, second power, third power, any trigonometric functions, the frequently language in the piece of paper is like that, sine squared theta. But this is equivalent to say sine theta squared. Entonces, to omit the parentheses, you put in this notation. Okay? Pero es equivalent. Es the same. Okay, don't confuse it with the sine theta squared. Because this is a square first, the argument, and after you compute the trigonometry. To understand much better this, the efficiency way to do this is using parentheses, no? So now you suppose que it's square. According to the order of operation, you square theta first, and finally, you are doing the sine function. In this case, it's different. In this case, you are doing first the sine function, and after, you square. Clear? This is classical confusing. Not only for students, for everyone. Okay. Now, let's continue. Entonces, plus cosine theta doesn't affect the sine squared equal 1. And you know that when you square negative something is positive. No? So sine squared theta plus cosine squared theta equal 1. And this is the famous trigonometric identity que say que sine squared theta plus cosine squared theta equal 1. Boom. And we prove that this identity is okay. Any questions so far?
No questions, Professor. Can I take a picture?
Let me know when you finish.
Thank you. Professor, are you recording?
I suppose que yes. Let me see. Let me check it. Yes. Yes, no. Okay. Let's erase everything and move to the next page. Next page is, let me see, the review. This one. Okay, good. I need, this is a little bit more complicated, but no super big deal. Look, suppose tangent U, paréntesis, cosecant U minus sine of U is equal to cosine U. I need to prove that. We're doing 19. Well, first of all, in my opinion, I don't know, I have no idea. You start doing something, algebra, simplification. When I saw parentheses, you remove the parentheses, apply distributive property. You distribute here. The tangent U, time, cosecant U, don't forget the argument, minus tangent U, time, sine U. Should be equal. I need to prove that cosine U. Entonces I don't touch. I make a decision. So there are more degree of freedom, manipulation in the left-hand side than the right-hand side. Okay, just one more time. I'm using the famous trigonometry, tangent is sine U divided by cosine. One good idea, not always, not 100%, but 99% of the case of the scenario, if you will be able to convert every trigonometric function using sine and cosine, it's good. By the way, this is the technique using the software. So in the software online or graphic calculator is available in the market, offer the answer. So when you put in calculus, you put it, you something, and this something involved trigonometric function, the answer que offer the calculator or the software is using only sine and cosine, and sometimes tangent. Pero no cosecant, never cosecant, cotangent, and secant, no. Entonces, maybe in the piece of paper you are doing by hand, using every trigonometric function, and when you verify using the software, this software que I show you online, give me an answer different, ¿no? Pero es equivalent, ¿no? Okay, es equivalent. Entonces, good idea, not always. I do not generalize, que es 100%, but a good idea is convert any trigonometric function to sine, cosine, and sometimes tangent. And cosecant es obvio que es reciprocal of sine. Likewise, sine U, cosine U times sine U equal cosine U. Wow, I like that. This is cancelled out. Pam pam. This and this, no. Why not? Because sine and sine is in the top. So this is a square. So basically, so far we have 1 over cosine U minus sine square u divided by cosine. Everyone follow me so far?
Yes.
Now why no? There are no reason to have two fractions separately. No. Yeah, by the way, I have the same trigonometry, the same denominator. Entonces now I join, put together cosine u, este common denominator, 1 minus sine square u equal cosine u. Wow. Entonces now this look like a little bit similar, not exactly the same Pythagorean identity. I want to explain it now. I know by memory, or I look in the cheat sheet, que sine square u plus cosine square u equal 1, always. Therefore, si you isolate cosine, cosine square u is equal 1 minus sine square u, que is exactly the same we have here. And you can replace, no 1 minus sine square anymore. It's cosine square u divided by cosine. Only one cosine. It's obvious que at least one cosine is cancelled. So now it's 2 minus 1 is, cosine square is cosine times cosine, no? Cosine times cosine, no? And you see that one cosine is cancelled and stay alive, only one cosine. Entonces cosine u equal cosine u. Boom. Final answer. Proof. What trigonometric function? Well, some algebra we're using distributive. Some algebra we're using compact to fractions. The famous tangent identity, que is sine over cosine. And the Pythagorean again. Wow, Pythagorean is very important. Very, very important. And that's it. End of story. So Pythagorean, we have a collection. Is the most popular is sine square plus cosine square equal 1. We have another que is secant square, que is also Pythagorean, is tangent square plus 1. And we have another que is cosecant square u or theta, either way, is cotangent square u plus 1. And this and this and this belong to the same category, Pythagorean. You need to be aware to replace. Secant square is tangent square plus 1, or cosecant square is cotangent square plus 1, or cosecant square is 1 minus sine square, or sine square u is 1 minus cosine square. Guys, in calculus, you need to using this like a game, flow. And the teacher, wow, want you learn very well this, okay? I know it's a process in trigonometry. This is my responsibility. But when you finish that, I need to guarantee you at least for 3 months, you memorize these equations. Any equation and number, what is the number we're doing? 19, no?
19.
19. Take a picture. Let me know when I continue.
You can continue, Professor.
You feel comfortable in the identity?
Yes, that one was easy.
Entonces, I don't want to put it complicated. No. Because there are identity I cannot solve it. I tried several times. I cannot solve it. You, in the real life, suppose you need to prove something. We can use in software. And you put this, suppose this. Cosecant square minus cosine u multiplication secant u should be cotangent square u. You suppose another more complicated. Okay? You cannot prove by hand. You put in the software, and you put the left hand side equal on the right hand side, and you copy both, and you press enter, okay, and the answer is yes identity, say true. That means it's true for any value of the u or the theta or the whatever, right? And si yes no identity, it's equation, because equation is different. In the identity we have infinity many solutions, right? In the equation, no, we have solutions, que es when they are coincidences, pero es no infinity, it's a finite number of solutions, 2 solutions, 3 solutions, 20 solutions, but no infinity solution. Got it? Identity is different. It's a particular example of the solution in which you have infinity many solutions. I suppose I explained in the lecture very well this, or no? You need another extra information to understand the thing we are doing is establish identity. Identity. Okay, let's do an identity. Well, I have no idea, I'm totally lost. However, I don't know, pero this smell que we finish in Pythagoras, ¿no? Entonces cosecant square u stay like that, minus cosine u stay the same, but secant es reciprocal. Reciprocal cosine. Wow, I canceled this thing. Since cancelled, then we have cosecant square u minus 1 equal cotangent. So I refresh your memory of the Pythagorean, say I copy exactly of the way that you see in the cheat sheet, que cosecant square is equal cotangent square plus 1, or 1 plus cotangent, doesn't matter. And you replace, no cosecant square anymore, it's cotangent square u plus 1 minus 1 equal cotangent. This and this say goodbye, cancel out, and stay then cotangent square equal cotangent square. It doesn't matter the expression, but when you get identical twin brother expression, you prove and you stop. In this case, I'm using one more time reciprocal identity is the most popular, and Pythagoras. This Pythagoras. No, this Pythagoras, sorry. No, this, you know this. Pythagoras. Okay. Very good.
Yes.
We are doing a slow down because my intention that you understand. I don't know exactly what the way you study. Well, and the written test, you have to test at home, and you check the review again, or check the video, no? The number is different in the test, but the idea is the same objective in the problem. So I suppose you have no problem. This is the intention. And Alex, no, Alex is more complicated. Alex is a bad guy. You need to use your imagination. Remember this Wednesday, I am in the tutor service, student can want. Okay, another student cannot the Wednesday, another day with the Jose Alegre. 21st now. 21st say sine x. Now I change the variable. Multiplication tangent x. Cosine x minus cotangent x multiplication cosine x. And this is equal 1 minus two times cosine square x. This is the identity. Okay, I need to prove. Well, again, why not distribute the property? This and this. We have so far sine x times tangent x times cosine x minus sine x again cotangent x cosine x equal the same repetition. Repeat. Okay. I don't need to write this. So you bring down in the last moment. Now, one more time, I suppose. I don't know exactly, but I suppose que we use tangent cotangent identity. Entonces, sin x, multiplication, sin x, divided by cosine x, times cosine x, wow. Time cosine x, because at least I know, I saw que this is cancelled, no? But this is in the next step, no? Minus sin x, cotangent is cosine over sine, opposite, reciprocal, or time cosine. Because I see again that we have cancelled out this and this, no? Okay, not bad. So now we have sine is sine square minus cosine square. I know that sine square plus cosine square is equal to 1, but I have no idea what is sine square minus cosine square. I am lost, I don't understand this. However, I come back again to the famous sine square x plus cosine square x equal 1. And I maybe replace sine. What is the reason I know that you replace sine square? Because my right hand side contains only cosine. So I need to do something in order to eliminate the sine. Sine square x is 1 minus cosine square x. Okay, not bad. So I replace 1 minus cosine square x minus another cosine square x. We continue on the same line. It's 1 minus twice, because the negative 1 and negative 1 together. Cosine square x is exactly the same of the original right hand side. Boom, I finished my proof. Crystal clear?
Yeah, that was good.
Okay, you see it's very, very frequently you are doing some small algebra. You're using this identity is super important. And this is super important also. Tangent and cotangent is the name of this identity. And the Pythagoras, one more time. No reciprocal in that case. No even odd, no. Only tangent, cotangent identity, Pythagoras. But Pythagoras que involve sine and cosine. Very good or no?
Good.
That was number 21, no? 21. Guy, everyone follow me. Come on, I need to know opinions. You feel okay? Opinion. Say Jorge, Kevin, say I got it, professor. Okay, super. I know that you are good. Yeah, but I am a little bit concerning this class. I explained the last lecture because there are several students who take this class for the second time. Okay? And not always we are doing well in the first test. So I suppose that you now improve in the second. Okay, let's move on. 22. 22 is piece okay. I understand very well 22. It's easy. It's cotangent square x is equal parenthesis cosecant x minus 1 multiplication cosecant x plus 1. Wow. This look like the famous product that we are doing in algebra, que is a minus b times a plus b, no? You remember the conjugates, multiplication, and the answer is a squared minus b squared, right? It's a classical difference of a square, that when you apply in that direction, a factorization, but when you apply in that direction, a multiplication, no? But if you don't remember this, no problema, because you apply FOIL and in the story. You multiply. For example, it's obvious that I don't touch the cotangent square because it's only one guy. We have no degree of freedom to manipulation. And your multiplication, cosecant times cosecant, is cosecant square. Cosecant times 1 is cosecant. Minus 1 times cosecant is minus cosecant. and -1 and +1 and -1. Wow, this is cancel. Always happen. Why happen? Because they are conjugate. And stay only cosecant square x minus 1 equal cotangent. Well, look like familiar, but not super familiar, because on the sheet I can see que cosecant square theta is equal 1 plus cotangent square theta. So you replace no cosecant anymore, is 1 plus cotangent square theta minus 1. Entonces es obvio que +1 and -1 is cancelled, and stay only cotangent equal cotangent. Cotangent square.
Professor, what is cotangent? It doesn't need to be x. Why is theta?
No, sorry. It's x. So the original variable in our problem is x. But in the identity, when they see in the piece of paper, maybe Nuela, we see theta. So I confuse him. It's x. Got it?
Yes, I got it. Thank you.
In my problem, the variable is x. I don't want to change that. No, hello. However, this is the thing que I saw in the cheat sheet. Good or not good?
Good.
Let me know when I am ready to erase.
You can.
Okay. Okay, now 20 seconds, no? 22. No, 22 I did, huh? Is it 22, right?
23.
Yeah, 23. Okay, 23 is. Let me copy directly to the page. Secant u. Secant u plus tangent u. I need to prove que es equal always 100% with the cosine u divided by 1 minus sine u. This is a little bit more complicated. But I want to explain the fantastic way for doing that. I suppose that you remember a little bit the conjugate. For example, when you in algebra, we have this expression que is 1 over 2 plus radical 3, and you want, for example, rationalize this as a binomial. You multiply by 2 minus radical 3, 2 minus radical 3. Why? Because this is the conjugate of this. And this is fantastic because it allows eliminate the radical in the denominator. Because the multiplication when you are doing FOIL here is 4 minus 3. So 2 times 2 is 4, and radical 3 times radical 3 is 3, and the other part disappears. Do you remember that, right?
Yes.
And in the top, we have 2 minus radical 3, because 1 times something is something, and 4 minus 3 is 1. Wow. So the answer is 2 minus radical 3. It's a fantastic way. And we're using this. And so I recommend when you have fraction, in the denominator of the fraction, we have binomial, like this case, binomial. One fantastic way to manipulate is multiply by a conjugate. What is the conjugate of this? 1 plus sine u. In order to doesn't affect, you multiply by this. Okay? Okay, so I copy the same, I bring down secant plus tangent. Let's see what happened in the right-hand side. In the right-hand side, we have in the top cosine u multiplication 1 plus sine u divided by multiplication this. And the shortcut to do fast is 1 squared minus sine squared. Yes or no? Okay, one more time, look. Okay, you need to improve your algebra, guys. Definitely. When you multiply a plus b times a minus b, you realize that this is a special product, and the answer is a squared minus b squared. We can FOIL, of course, like a kindergarten guy. However, I know that multiply a times a, b times b, and minus in between, no? In this case, I multiply 1 times 1 is 1, sine times sine is sine squared. Got it, got it, got it?
Yes.
Okay, now I know with the trigonometric identity Pythagorean que say que sine square plus cosine square is equal 1. Suppose que I want to isolate cosine. Cosine square is equal 1 minus sine square. It's identical to this. So I can manipulate this like you replace 1 minus sine square for cosine square. And at the top we have cosine u, 1 plus sine u. Okay. Oh, I saw okay, at least we can cancel out one this and one of that. Yes or no?
Yes.
Because cosine square, I know que cosine times cosine, no? Entonces, this cosine is cancel with this and stay only one cosine alive, no? Entonces, 1 plus sine u divided by cosine. Almost I finish. I split this common denominator. Sometimes it's convenience condensing, sometimes no. Depending on the problem, there are no rule. You split this common denominator like a 1 over cosine plus sine u divided by cosine u. And it's cotangent. This is secant, sorry. This is secant because reciprocal cosine is secant. And this is tangent. It's exactly the same thing. Wow, very good. That was 23, no? And 24 is, it's a 24. Yeah, 24 is very good. No, it's easier. Okay, 24. So you don't frustrate with the identity, no? Because there are no specific procedure. There are a lot of combinations, but basically we are using reciprocal, Pythagorean, this common denominator, distributive property. Sometimes convenience split the fraction in two, but sometimes no. Sometimes you condensing only one fraction. Okay. Entonces es strictly necessary. This is the traditional, the most elegant way to do that. You never touch one side and you try to manipulate, pero not always happen. Always happen que it's very complicated. No, and it is not complicated. And you need to manipulate both sides. But you cannot move like in algebra to another side. No, you manipulate this to get one expression. You manipulate this and you get the same expression. But no interchange. No interchange. You say something? Some student asked me something? I hear noise. No, voice. Okay, so now let me erase that part. Forget about. In our problem, always you stay one side. You decide the side que contain less information, and you take the side more complicated. And now you manipulate. Let's see 24, que is easy also. Tangent u minus 1 divided by tangent u plus 1 should be equal 1 minus cotangent u divided by 1 plus cotangent u. Well, in this case, you say, well, professor, I can apply conjugate. No, in this case, no. Well, I did different. Maybe you can. But no, I did different. So in my mind, I am a little bit more familiar with tangent and cotangent. I not hit the tangent, the cotangent, but I am familiar with the tangent. So I feel more comfortable manipulate tangent and cotangent. Entonces, pero I know that they are reciprocal. Entonces, I make a decision. I don't know you. Don't touch the left and touch the right in order to convert cotangent to tangent. So I have 1 minus reciprocal of tangent divided by 1 plus reciprocal tangent. You follow me?
Yes.
Entonces now, well, okay, I have a complex fraction. Well, I dedicate to manipulate the top part. I saw that the least common denominator is tangent u, because the only guy is 1 here. Entonces 1 is nothing. Entonces tangent u minus 1. Do you see the transformation I did that or no?
Yes.
Likewise, in the bottom part, the LCD is tangent u. And we have tangent u plus 1. Got it? Similar. So you not necessarily, you have fractions. Suppose 1/2 plus 1/3 divided by 2/5 plus 4/7. This is crazy, no? You find the LCD, no? It's 6. And the top and the bottom, no? It's 3 plus 2, no? It's the procedure, right? And this is 35. And this is 14 plus 20, something like that, right? And you adding. This is the way to face that problem. Entonces, in the last moment, well, it's a complex fraction. So you copy the fraction on the top exactly the same. Multiplication, the reciprocal of the fraction at the bottom. Wow, I can see clear que tangent is cancelled. And stay only tangent u minus 1 divided by tangent u plus 1. Boom. And this is exactly the same of this. Tangent u minus 1 divided by tangent u plus 1. It's the only way to do? No. Another student said, no. I prefer manipulate the tangent to cotangent. Okay. I suppose you get the same answer. I suppose. You don't need to do it in several ways. Only one way gets good is good for me. What number was that? This was 24, no? 24.
Yes, 24.
Let's move on to the sums of differences. Okay, sum of differences. Okay. Oh. Okay. We have time. Sum of differences. I want to erase that part. You let me do that. 25th. 25th is another topic. No more identity so far. I suppose in one moment of the review we come back again to another kind. Okay. They say find the exact value of the expression. Okay, remember, we know by memory, or the student can memorize the fundamental angle 0, 30, 45, 60, 90, 120, and so on. In the second quadrant, the third quadrant. This is the fundamental. However, there are another angle that is not fundamental. So this angle that is not fundamental, well, suppose when you are doing the application in the chapter 3, you don't need to know the final answer, the exact answer. No. You need the approximation answer to solve any problem of the physics engineer or something. And you put on a calculator and end the story. But in this case, no. In this case, they want to practice. You compute the exact answer. The majority of the calculator don't give me the exact answer. Give me the decimal approximation answer. So 25 say sine -11 pi over 12. Well. Immediately see negative argument. I don't like that. However, I take advantage that sine function is odd function. I put a negative outside. Okay. Now I need to investigate what is the angle. That angle is pi over 6 is 30 degrees. So I know. Okay, pi over 6 by memory is 30 degrees. Therefore, pi over 12 is a half, is 15. And 15 degrees multiplied by 11, so actually this part is 15. Multiplied by 11 is 165. And 165 lie in the second quarter. Okay, so I don't care temporary design. Yeah, using my famous formula of the sum of the angle, okay, say. So I know, let me copy here. 11 pi over 12. I know que es 165 degrees. I convert to degree, become degree. I can see more clear. So the combination can give me addition or subtraction. I suppose que es 120 and 45. So because it's 165. So okay. See, I want to find the sine, the exact value of the sine 165. We can interpret it like a sine 120 plus 45. Yeah, I know very well the trigonometric function of the angle because it's fundamental. So you decompose according to the formula. This is alpha, this is beta. Remember the formula says sine alpha cosine beta plus cosine alpha. I copy the formula for the cheat sheet. Sine beta. In our specific example, alpha is 120, so sine 120 degree cosine 45 degree plus cosine 120 degree time, sorry, no plus, no minus, time sine 45 degree. I try to find in the unit circle, on the table, either way, the way you prefer, what is this value? And you be aware in what quadrant lie, 120 lie in the second quadrant. Yeah, I know that the second quadrant, the sine is positive, but the cosine is negative. 45, no. 45 has no problem because 45 lie in the first quadrant, and any trigonometric function in the first quadrant, angle of the first quadrant is positive. So this guy is radical 3 over 2. This is the exact value. We are talking about exact value. No, in the calculator, no. The calculator puts sine 120, you press enter and give me the decimal approximation of this number, right? Time radical 2 over 2 plus, and cosine 120 is negative 1/2. Be careful. 120 is an angle que lie in the second quadrant. Let me suppose que I have no calculator, I have in the jungle, no software, no nothing. 120 lie in the second quadrant, like that. 120. I know que cosine in the second quadrant is negative, no? Remember the mnemonic device, all students take calculus. The only trigonometric function that is positive in the second quadrant is sine. Sine and his brother o sister, que es cosica, pero cosine. Cosine is positive in the first quadrant and the fourth quadrant. But the reference angle, que es alpha, que es the guy que helped me to understand any trigonometric function, is 60. es 60. Entonces, I know que the value associated with the cosine and sine of the 120 is exactly the same sine and cosine 60. But the only difference is the sign, and you adjust the sign according to this idea. So in my mind, I go to the cosine 60 degrees, que is 1/2. But I know it's negative because lie in the second quadrant. Everyone follow me with this idea? Everyone follow me? This is the idea. This is now we are working trigonometric. Es radical 2 over 2. Okay, leave like that. No, ugly. The rest is cosmetic part. Your multiplication, bueno, 2 times 2 is 4, bueno, radical 3, radical 2, you want put together, pero no. Minus 4 again, 2 times 2 is 4, radical 2. Now you're condensing, 4 is common denominator, radical 2 is a common factor, we have radical 3 minus 1. Boom, end the story, final answer, beautiful.
So, Professor, sorry, do we need to present like that on our written test?
Yeah. It's like that. O sea, I give you, Nuela, one angle in radian. I want to complicate. But wait. I forgot the most important moment. And the most important moment is that we have a negative here waiting for us. You remember that?
No, I forgot.
Me too. I explain different things, I forgot. But no problema. Because the answer is, when you change the sign, it's negative here and positive here. So now my answer is radical 2, 1 minus radical 3, no? Over 4. Under the consideration the negative outside. Okay, by the way, is the option, wow, it's no, so they multiply, look, another way to express this, doesn't matter. I like this way, however, in the answer no, radical 2 times 1 is radical 2, and radical 2 times radical 3 is radical 6, over 4, it's the answer that they want. Okay, is the option, what option? The A option, no? Radical 2. Yes, it is a radical A option. Do you follow me? Yeah, I know that there are too many details. So let me summarize everything. Number 1, apply the property odd function sign. I remove the negative inside, the argument outside. Secondly, so you feel more comfortable with the degree, not radian, you recommend convert this angle to degree, 165. Now, this kind of question, you're using the sum of different formulas. So you decompose 165 like a 2 fundamental angle, 120 and 45. You apply the formula, apply the corresponding signs of each trigonometric function, and don't forget, like me, the last negative one can affect everything, and change the sign. Any question? Wow, fantastic. Everything okay, Nuela?
It's good.
Okay, another students? At least say, I follow a professor. Or you are asleep? Yes. Okay, let's move on to 26. 26 is cosine. You need to find cosine. Cosine 5 pi over 12. Oh, I analyzed this before. I know that pi over 12 is 15 degrees. No? A multiplication by 5 is 75. It's 75. So I discovered that 5 pi over 12 is 75 degrees. Remember, guys, the formula, not necessarily doing that way. I do use intuition, no? But the formula is you divide by pi and multiply by 180. No? This pi is cancelled. And I stay 5, 180, and 12. Entonces, I suppose que 180 is even number, is divisible by 12 somehow. 180 divided by 12 is 15. Entonces 5. So I did that part. The answer is 15. And 15 times 5 is 75. Either way, intuition, formula, doesn't matter. So basically, I need to find the exact value of the cosine 75 degree. Well, entonces I have no idea, I'm lost, pero I know que the combination 75 is 45 and 30, right? When you add in this guy, it's 75. So one more time, we're using the formula of the cosine alpha plus beta. And the cheat sheet. So in cheat sheet, we have one formula que es cosine alpha plus beta. Who is alpha, who is beta? In our particular example, well, cosine 45 plus 30, no? Que es 75. It doesn't matter the order because it's plus no importance. If minus, yes. And the formula say cosine 45 multiplied by cosine 30 minus the formula is weird because the one is plus inside is minus outside. Sine 45, sine 30 degree. And everything is nice because the original lie in the first quadrant and the decompose que 45 and 30 lie in the first quadrant, so everything is positive. Radical 2 over 2, radical 3 over 2, radical 2 over 2 again, and 1/2. So you don't know by memory, don't problema. You look at the cheat sheet. I know that this is a process similar to the multiplication table. And little by little, my intention is that when you take calculus, the professor of the calculus say, what is the sine 30 degree? And everyone know that sine 35 degree is 1/2. So you don't know in this moment, you are stupid. For me now, no, you are good. You are student learning trigonometry, right? Okay. Now I feel no, the cosmetic part. Is a radical 6. According to the language of the package, they want you multiply this minus radical 2 over 4, no? Because the LCD is 2 times 2 gets 4, and it's the answer. And this is the answer here. Okay, they want get the option. Let me see what option is correct. Oh no, they using another way. They using, let me see, radical 2, radical 3 over 4 minus radical 2 over 4. This common denominator 4 and radical 2 is a common factor, radical 3 minus 1. Not like that. It's equivalent, you know, but I don't know, they prefer no multiplication de radical, like the option A. Again. Good?
Yes.
Ah. Wow. Too many details, eh? In trigonometry, right?
Yeah.
So you are not systematic students. You don't study. Because you cannot condensing this too much information. And this is just the beginning. Because now in the third chapter, in the fourth chapter, is the application of this. No? As I suppose that you know everything. Okay, tangent, 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 now tangent, 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 compute tangent of 13 pi over 12. Well, pi over 12 again is 15 degrees, no? Okay. 15 degrees. Okay, entonces, pero multiplication by 13. 15 times 13 is 100. So basically, this is equivalent to say tangent 195 degrees. Bueno, the combination I suppose que es 150. You decompose 195 and 45. Makes sense, right? It's the couple, alpha and beta. This is the couple. This is the couple of the component that you know very well the exact value. I know very well the exact value of the tangent, cosine, sine of the 150 and 45 degree. Well, so this is some students say, no, professor, this is the complicated part for me. Well, not complicated because when you see the ending, the number ending in 5 is because 45 participate in the game, and you try to find subtracting 45 at 150. Okay? Now, si es ending in 0, no. Entonces now, it's impossible ending in 2 and 3 because the fundamental angle that we studied, the only guy gets different is 45, 135, 225, ending in 5 or 0, 240, 270. Okay. Okay, entonces I go to the formula. The formula say tangent 150 plus 45. The formula say, in the cheat sheet you can see tangent 150 plus tangent 45. That is alpha beta. It's tangent alpha plus tangent beta divided by 1 minus, when it's plus here is minus, when it's minus here is plus, multiplication, tangent 150 degree multiplication tangent 45. Do you see this formula in the cheat sheet?
Yes.
Okay, let's do it now. Go ahead. Question.
No, I said it's on second page.
And the second page is the most important page. Okay, the student one can copy again that formula like the original and the cheat sheet, or show you the cheat sheet. Because I have on my computer, I put in the blackboard, in the whiteboard, sorry. No. A ver, no la dice no. Pero bueno, este no es la opinión, no, another opinion. Okay, entonces tangent 50 degree. Oh, I have no idea, I lost. 150 degree. This is my problem. Now, okay, look. 150 degree lie in the second quadrant. Here. Y I know que tangent in the second quadrant is negative. So that number give me negative number. And this give me also negative. 45, no. 45 lie in the first quadrant is positive. Okay, by the way, tangent 45 is 1. Because in the 45 degree, sine and cosine is the same, no? Radical 2 over 2. But 150, no. 150, the reference angle is 30 degree. And tangent 30 degree, I don't know si you memorize or no, es radical 3 over 3. Okay? Es radical 3 over 3. Okay, entonces we have so far minus radical 3 over 3 plus 1 divided by 1 plus, because we have negative together, positive radical 3 over 3. Do you follow me?
Yes, Professor, but it needs to be negative, right?
Who is negative?
Because like if you see like on the denominator of the equation, we had like -1, and then you put plus on the second one.
The reason was que dice negative radical 3 over 3, ¿no? And it's 3. So
no, Professor, I'm talking about the denominator. It's 1.
I know. This is negative radical 3 over 3, ¿no? Pero negative, negative becomes. Okay, entonces what should I do? Well, are you condensing one common denominator? Maybe it's 3. And we have 1 minus radical 3. I put a negative in the second place. Either way, and 3 again. 1 plus radical 3. And these 3, I don't know, so you see gets cancelled out. Yes or no?
Yes.
And that says 1 minus radical 3 over 1 plus radical 3. I don't know si they want you leave it like that or no. or rationalization, or I don't know. Let me see. Oh yes, rationalization. So the answer, we have not this value, is because the guy is solving this, never leave it like that, continue algebra and rationalization. Okay, no problem. Let me try. Remember the conjugate is 1 minus radical 3. 1 minus radical 3. At least I know que in the denominator the answer is 1 minus 3. Okay, remember this is a plus b times a minus b. The answer is a squared minus b squared. A is 1 squared, que 1 squared is 1, and radical 3 squared is 3. Entonces 1 minus 3 es negative 2. At least the denominator is negative 2. In the top, no. In the top, you FOIL. 1 times 1 is 1. 1 times negative radical 3 is minus radical 3. Minus radical 3 again, because this and this is a plus 3. Okay, so far we have, let me see. It's 3. 1 plus 3 is 4. Minus 2 radical 3 divided by negative 2, no? Because 3 minus 1. 1 minus 3 is negative 2. This is now 4 divided by negative 2 is negative 2. And negative 2 divided by negative 2 is 1 plus radical 3. Wow, I suppose this is the answer after the rationalization. Let me see. It's negative 2 plus radical 3.
Professor, sorry, if we have this exercise on the test, can we leave like that?
Yeah. Remember, our test is no multiple choice.
Okay.
Our test is no multiple choice. Then, let me check it. The answer is minus 2 plus radical 3, que is equivalent to 6 radical 3 minus 2, no? Yeah, it's this, it's C. Noela, there are no differences, only cosmetic part. Rationalization is no mandatory operation. It's only to see more clear. Do you see that this is ugly? And this is nice. Yes or no?
Yes.
You see the difference? Like, so you know the algebra, you can do that. But no. So you leave it like that, 100 points for you.
Okay, thank you.
Okay, this was 27. 27. Now, 27. Okay, guys, I propose you stop here. Remember, we continue.
Yeah.
We continue Thursday, no? So we dedicate almost 3 lectures for doing the review. I suppose we are discussing in detail. Yes or no?
Yes, Professor, yes.
You have no excuse to fail. Okay?
Professor, you have time. Do you have another class?
Yeah, you have another class now.
Oh, okay. I'll go to your office hours on Wednesday.
Okay.
No problem. Thank you.
I'm waiting for you.
Okay, bye-bye.
Bye. Bye, guys. Let me